Good afternoon everyone, I'm Chen and my topic is object retrieval from a large corpus. I do not want to bother you with algorithms, so I skip that part in my presentation. I like to emphasize the idea that researchers proposed to solve the object retrieval problems. So first let's see an example. This is a picture I took a month ago, and I'd like to see more pictures containing this specific species of duck, which are more energetic one, I think. So I uploaded this on Google Image, and here's the result the Google Image offers. This is a bunch of pictures containing people, sheep or cows, I think, and also many pictures does not contain any animals on it. Certainly this result is not satisfying, so I'd like to figure out why object retrieval is difficult and how to achieve a good result. According to my research, I found there are mainly three problems. Our problem, not the return of investment. This is a region of interest problem. And the second one is bag of visual words model problem. And the third is large corpus problem. We can see. For the first one, there's not a clear definition of the object of interest. For example, we cannot simply say a nose is an object retrieval of a human face. And for the second one, it is often ambiguous to define an object of interest. For example, if I have a picture with a bee on the flower, it's hard to tell whether a bee is an object of interest or the flower is. And it's difficult to separate complete objects. For example, in the real world, object does not appear separately, so it's hard to pick out the objects from a complex scene. And if we followed the conventional segmentation methods, this situation often appears. And for the first scenario, we can see the building as an object of interest, but the bounding box also conclude like this part, the branches of trees, also a human, also a car. If we extract features from this bounding box, this part will definitely will influence the final results. And for this one, if the ROI, the region of interest, is too small, it cannot contain many texture or cannot offer sufficient visual words to match with other images. So we can see the results. There's an image with human, and these are the unrelevant buildings. So there are many approaches to solve that problem. These methods are before the 21st century, kind of old. So I do not to explain more about this one. But for this is more the recent research. So the old methods mostly focus on the region of interest, but the context also offer extra information. So the recent methods also take that into consideration. And this one is very interesting. They assume that the interesting object is in the central part of an image, and the edge part is not that necessary. This is direct, but I think it's also efficient and fast matching with other images. And this is about the semantic categories, and this one is also interesting. For example, my hand is a window. It's just go through the images to find the region of interest. That makes the region of interest more reliable, but also it is very computational expensive. So this is a bag of words problem. First, the bag of words, it's caused to loss of spatial information, and also its deficiency of features discriminal powers caused by these two factors. And approaches. We can apply the spatially constrained measures. That means the match viral words with spatial consistency are only that part are taken into consideration. And voting-based approach, that means we build a voting map and assign to the database image which contain the same viral words with the query. And re-ranking method with this key nearest neighbors. The information around the object also similar with the images that contain the same object. So that also takes into consideration. And the large corpus problem. Why I limit my topic on large corpus, because if we like to search on the internet, it's obviously that the corpus is huge. So we have to think about the computation burden and the performance. For example, if I upload a picture and I got a very nice result after 10 minutes, the system still sucks. And also, building an image feature vocabulary is very time consuming if the database is very, very huge. And approaches. Basically, we have these two approaches. This is to guarantee that we have a large vocabulary, and this is about the performance. We still need to confirm the performance is good. Early system usually apply the flat k-means clustering. That was efficient, but it is hard to apply it to a large corpus. It is not that scalable. So most recent work focused on the hierarchical clustering. Using that part, it's extend the vocabulary a lot. I think to optimize the results of object retrieval, mainly focus on these three parts. For the query part, we can do like query expansion, or we add search intent scores to the matching part, or not to the matching part, to process the query. Also, we can weight the features from the query. About the matching part, most of the work apply language model methods, and they make optimizations of that methods to fit their purpose of object retrieval. And about the ranking part, we obviously want to offer a good result to our users and to rank it according to the relevance. And all this part we have to considering the computational expense, because if it's too much time consuming, it's still not feasible. And the future work, I think mainly focus on this four part. Personalized search, I think, is a future trend, because we can analyze users' behavior on the internet and his user other behaviors. For example, if a user likes Teddy Dog, he always downloaded pictures with Teddy Dog. If he uploaded a picture of Teddy Dog, we can assume that he still wants more pictures about a Teddy Dog. And the multimodal retrieval, people would like different media channels to combine together, so we can use a multimodal to get a more concrete, accurate result. And human computation, as humans have a greater ability of processing images, and at the current stage, I think human computation still needs to be taken into consideration to help the computer to understand how people think, what is the intent of people's queries. And also, I think intersections with other fields is in need. We can say, for the paper I referred before, the central extraction part, they think the object of interest is mainly in the central part of a picture. I think for most users, they took pictures and they like to put the object of interest in the middle part. But for most professional photographers, they have their own patterns to structure a picture. So this and the patterns to organize a picture is limited. So I think if we take this part into consideration, we can get more accurate region of interest. And this is if we combine images and text queries, we got this kind of results. Still not the same kind of duck, but at least they are ducks. Yeah. And this is a reference paper. And questions?
Let's thank the speaker.